Hello, this is a geometry video. It is chapter 4, section 3, congruent triangles. And before we get to the example 1, I would like to briefly take you to the textbook. And this is what your textbook will look like on page 255, I do believe. And I need you to copy down these figures and this definition of congruence and corresponding parts. So what we have, it says here, if two geometric figures have exactly the same shape and size, then they are congruent. And it's actually from this where we get our symbol for congruence, which is an equal sign with a similarity symbol. So I'm not sure if you know, but this symbol represents equivalent, equal, and this symbol represents similar. And so the congruent symbol is a combination of both of those put together. So the equal part would come from the same shape, and the equal size would come, the equal would come from the exact size, and the similar comes from it being the same shape. So you put those two together and you get your congruence symbol. And so we have these little fishies. All of these fishes are exact same shape and size, even though they're positioned differently, some are rotated and whatnot, they would be qualified as congruent. But in the not congruent, they look very similar, but you can see, for example, 4 and 5, they have the same exact shape, but this one's smaller than that one, so they're not the same size. And then when you compare 5 and 6, they're more the same size, but they don't have the same shape. The line here, the segment right here, has more of a slant on figure 6 than figure 5. So just some examples of congruent versus not being congruent. We also want to kind of scroll down here a little bit. Oh, hold on. Having some issues with my board here. So once you've done that and you've copied down that portion of it, we also want you to write down this portion down here, if I can get this to be where I want it to be. We're going to talk about congruent polygons. It says, we talked about congruent and non-congruent and what that means. But right here we have in bold, if I can get this positioned correctly the way I want it. Okay. Right there, okay. So it says, in two congruent polygons, all of the parts of one polygon are congruent to the corresponding parts or the matching parts of the other polygon. And it doesn't just happen for triangles, it happens for any type of polygon. So these corresponding parts include corresponding angles and corresponding sides. Of course, they do have to be corresponding. So what we have here in the diagram is a figure, a picture that speaks hopefully better than the words do. And we've got two triangles here. And you can see that the triangles are actually flipped. For example, the longest side here, which appears to be AC, is on the bottom of this triangle. But in this case, the longest side, which is HK, happens to be the top of the triangle. So they've kind of flipped the triangles around, but that does not affect the corresponding parts. Excuse me, sorry about that. And so, two polygons are congruent if and only if all of their corresponding parts are congruent. So what we have here is everything's color-coded. And for that to take place, it means there are actually 6 parts to the triangle. There are 3 pairs of angles, and there are 3 pairs of sides. And so what we have here is 6 different statements, and they're all color-coded. So we have angle A, which is marked with 2 small arcs, and angle H also marked with 2 small arcs. So that's kind of how you know which one goes with which, if you can't tell just by looking at it, is by counting the arcs. So we've got 2 arcs to 2 arcs. We have 1 arc here for angle B and 1 arc for angle J. So we have that angle B is congruent to angle J. And then we have angle C, which has 3 arcs, and angle K with 3 arcs, and again they're in green, and we've got them marked as congruent. And then we have corresponding sides. So again, with the sides, we use these little tick marks, these little dashes, if you will. And again, the same is true, 1 to 1, 2 to 2, 3 to 3. So we've got one tick mark here. So AB is congruent to one tick mark here, which is HJ. And then we've got BC with 2, and then JK with 2. And then we've got AC with 3, and we've got HK with 3 as well. So those are the corresponding sides, and so we've got those marked congruent. And then we have what they call a congruent statement. This is the part that most people forget about in the homework. It will ask you to write the congruent statement. A congruent statement is just that, a statement that says that two things are congruent. So when they ask you for the congruent statement, they want you to write out that because all of the corresponding parts are congruent, then triangle ABC is congruent to triangle HJK. And this is very important. The order in which you list the letters over here matters. It matters a big deal. Okay, all of the letters have to be in the same order that they are in the triangle. In other words, if I write triangle ABC, then I have to write HJK. In other words, A corresponds with H, B corresponds with J, C corresponds with K, and they're in the same position in the statement. So you can see down here at the bottom of the screen, it's kind of hard to see it there, but let me help you out a little bit here. Looking for my screen here. That's right there, okay? So that you can see a little bit better how it says here, other congruent statements for the triangles above exists. Valid congruent statements for congruent polygons list corresponding vertices in the same exact order. So see, we named it here ABC. You don't have to call it ABC. You can call it BCA. But if you do that, then you have to change the order of this as well. So if B is going to go first, then the angle that corresponds with B, which is J, has to go first over here. And then since C is in the middle, the angle that corresponds with C, which is K, has to be in the middle. And then last A, and what corresponds with A is H, so H is last over here. So you have to write them in the right order. This would not be in the right order because you have A corresponding with H in the right order, but B does not correspond with K. So they're in the wrong order here, so this would not work. So you want to be really careful that when you list the congruent statement, that you write them in the right order. Okay, so now that we've done that, now we can actually go and talk about the examples. Okay, so here we have our first example. It says show that the polygons are congruent by identifying all the congruent corresponding parts, then write a congruent statement. So the first thing I have to do, I know it seems kind of tedious, is actually go through and identify all the corresponding parts. Remember, there are 6 of them. There are 3 pairs of angles and 3 pairs of triangles. So here we don't have anything that's color-coded, so it's very important that we follow the markings of the diagram. And this is not a triangle, it's a quadrilateral, so instead of having 6 parts, we're actually going to have 8 parts, 4 angles and 4 sides. So I'm going to start first with the first arc. We see here in this top triangle that we have an arc, one arc, and that's angle P. So, oops, how did that get over here? We need to move you back. Okay. Hold on, people. Trying to figure out what's going on here. I'm not sure why that turned on. Okay. Why are we on page 25? I have no idea. I apologize for this interruption here. There we go. I think we're in the right video now, but we're in the wrong page still, so I'm just going to go back a little bit. Okay, here we are. Sorry about that. So, okay. Okay, I think now we are finally ready to do this. Okay, sorry about that. Okay, so as I was saying, we have angle P that has one arc. And as I look at the other figure, I look for the same angle that has one arc, which is angle G. So then we have angle G. And then we want to go to the two arcs. So we see that angle Q has two arcs. And that corresponds with the angle over here that has two arcs, which is F. And then we have the three arcs, and three arcs over here, angle R. And that corresponds with three arcs here, which is angle E. And then we have four arcs over here, angle S. And that corresponds with four arcs over here, which is angle D. So that's four pairs of angles. We do the same exact thing for the sides. So we want to go with the sides that have little tick marks. So we have one tick mark here, which is PQ. So segment PQ is going to correspond with segment GF. And notice also that we want to put them in the same order. PQ. P is the single arc and Q is the double arc. So when I come over here and I see this segment, I want to go from single arc to double arc. So I'm going to go GF instead of saying FG. It's GF. And then we want to go to the two tick marks, and that's going to be this one here, PS. And with PS, I'm going from one arc to four arcs. So over here, I'm going to go from one arc to four arcs. So I'm going to call it GD. And then we have three tick marks. So that's going to be SR. And SR is going to be from four arcs to three arcs. So over here, we're going to go from four arcs to three arcs, which is DE. And then our last one is the four tick marks, which is QR. And since QR is 2 to 3, over here I'm going to go from 2 to 3, so it's going to be FE. So now I have I've identified all my corresponding parts, and now to write the congruent statement, I'm going to say that the figure over here, I'm going to start with the single arc P, parallel or quadrilateral P, Q, R, S. And I don't have to call it that, but I just want to go from one arc to 2 to 3 to 4, so P, Q, R, S. So I have to go in that same order when I go down here. So the single arc is right here, G, F, E, D. G, F, E, D. G, F, E, D. And there you go. That is how you write the congruent statement and all the identifying parts. So now you're going to do the same thing for these two figures, and then we'll move on to the next example. Now in this diagram, there's triangle ABC, and they told us here that triangle ABC, which is this triangle here, is congruent to DFE, so we already know that they're congruent. And because they're congruent, that means that all of the sides are equal and all of the angles are equal. So they want us to find the values of X and Y. So we know that here this angle F corresponds with angle B. So we know that 8Y minus 5 has to equal 99 because they're corresponding parts and the triangles are congruent, so they have to be equal. And we also know that 2Y plus X, which is side FE, corresponds with side BC because B and F are in the same position in the statement and C and E are in the same position in the statement, so they're corresponding. BC corresponds to FE, so BC corresponds to FE. So we know that 2y plus x is supposed to equal 38.4. This equation has two variables in it, so we can't solve that right away, but we can solve this one because it only has one variable. So we do this and we get that 8y equals 104. Divide that by 8, and we now know that y equals 13. Now that we know what y equals, we can plug the y into the next equation, which is 2 times 13 plus x equal to 38.4. And 2 times 13 is 26. So if I subtract 26 from both sides, then x will equal 12.4. And just like that, we have found the values of x and y for this example. So now you're going to do the same thing in this example. Then we have our next theorem. It's a very simple theorem. It's called the third angles theorem. And I did a lot of abbreviating, so hopefully it'll make sense to you. But basically it says, if two angles of one triangle are congruent to two angles of a second triangle, and so here we have the two triangles. Here's two angles of one triangle congruent to two angles of a second triangle. Then by default, the third angles of the triangles are also congruent. That should make sense. You can do a really simple informal proof. Let's just suppose that, make this easy, let's suppose that angle C is 20. Well, that would mean that angle K is also 20. And if this angle is, I don't know, 50, then this angle would also be 50. And since these two are 50, and we have our theorem that says that all of the angles in the triangle have to add up to 180, well, 50 and 20 is 70, and 180 minus 70 is going to be 110. And over here, you're going to get the same 50 and 20 is 70, you're still going to get 110. So it should make sense that if two angles of one triangle are already congruent to each other, then the third angles would also have to be congruent. So basically what it's saying is that if angle C is congruent to angle K, and in turn B is congruent to J, then A and L have to be congruent as well. So we're going to use that theorem to do this example. And now this is the do-it-yourself question. I'm going to do the first part up here, example 3, and use the same figure for both problems. So I'll do example 3, and then you can do it-yourself number 3 on your own later. All right, but here we have a kind of a funky diagram. It's talking about napkins. I only drew the actual diagram that we needed and the information that was necessary. It has a whole word problem attached to it that you can read for yourself on page 257. But here we go. It says if angle NPQ, and it's important that we identify those angles. So here's NPQ. So we're talking about this here, this angle, and it's already marked congruent to RST. And so here's RST. So basically what you should be seeing is that there's two right triangles. There's one right here, and there's one right here, and they're kind of facing each other. So you've got two right triangles. It's kind of like this. There's a right triangle, and there's a right triangle. But they're overlapping, so it's kind of hard to see. But those are the two triangles in question, and so right now we're talking about that angle and that angle are congruent. So basically what we know is that this angle is congruent to that angle. If you were to separate the triangles, that's what it would look like. We also know that this angle is a right angle and that angle is a right angle because they're clearly marked. Okay, and we also know that NPQ, which is this angle right here, is 40. So this one is 90 and this one is 40. So if you want to make that diagram a little bit bigger so you can kind of see what I'm talking about, we know this is 90 and they told us now this is 40. And this is N, this is P, and this is Q. And I'm just separating them for you so you can see them better. This would be R, T, and S. Okay, so we already knew that angle NPS, which is NPQ, was 40 degrees. So here's NPQ, that angle right there is 40 degrees. and it's congruent to RST, so this is also 40 degrees. And what you have is that these two are both 90, so we have two triangles that have two angles that are already congruent, which means that N and R must be congruent. And they want us to find the measurement of angle SRT. SRT, they want us to find this angle right there. So all we have to do is go 180 minus 40 minus 90, which is 180 minus 130, and that's going to give us 50. So the measurement of angle SRT is 50 degrees in this case. Now we have some different information for you here that we want you to plug in and then find the measurement of angle NWR in a similar fashion. Alrighty, and then we go to our final example, example 4, and pardon me, that's the bell. But example 4 says write a 2-column proof. I know you don't like writing proofs, but they're not that hard. When you're trying to prove that triangles are congruent, remember that there's basically 6 pieces of information that you have to have in your proof. When you want to prove that two triangles are congruent, in your proof you have to state that the 3 different pairs of angles are all congruent and that the 3 different pairs of sides are all congruent. If you can do that, then you've proven that the triangles are congruent because all of the corresponding parts are congruent. So they've given us a lot of given information. They've given us a diagram. So I already put into the proof the stuff that was given. We know that DE is congruent to GE. It's marked. So here's DE congruent to GE right here. Notice that it goes from 2 arcs to no arc, 2 arcs to no arc. So we wrote them in the same order. DF is congruent to GF. So here's DF congruent to GF, and it's marked as well. So those things were already given. And that's 2 pairs of sides already. We need 1 more pair of sides, and it just so happens that that side is EF. And EF happens to be what we call a shared side. Both triangles are using side EF as one of their sides. So we mark the diagram with an X to indicate that it's a shared side. And when you have something like that, it means that you're using the reflexive property. Because EF is congruent to itself. The EF from one triangle, from this triangle, is congruent to the EF from that triangle because it's the same side. So it's reflexive. So it's very important when you're doing the proofs that you notice the reflexive sides, that you look for vertical angles whenever possible, any indication of parallel lines, because those kinds of things you're supposed to get from the diagram. It's implied in the diagram. They won't tell you, but you're supposed to know. So just be careful with reflexive, vertical angles, and parallel things. Okay, so then we go to step 3, and it's all about angles. So we have angle D is congruent to angle G, and that was given. So here's D and G. And then we have DFE, so angle DFE, and then we have GFE, and that was given, so that was really simple. So again, we have 2 pairs of angles that were already given, and so we need 1 more pair, and that would be this pair of angles right here that we need to have 3 arcs on it. And we can use the theorem that we just learned that says that if 2 angles of the triangle are already congruent, then the 3rd angles are also congruent. So we're going to write down that angle GEF is congruent to angle, and again, we're going to go in the right order. G has 2 arcs, E has 3, and F has 1. So we're going 2, 3, 1. So we have to go the same order for this triangle. 2, 3, 1. So we're going to go D, E, F. They have to be in the right order. All right? And that's going to be because of the 3rd angles theorem, which we just did right here. 3rd angles theorem. Okay? So we put that there. And now we've got 3 pairs of sides, 3 pairs of angles, and we can finally prove that the triangles are congruent. And we want to write the exact same statement that they wrote. Triangle, we don't want to do it in a different order. We want to make sure that it's the same as the one that was previously there. So DEF is congruent to triangle GEF. And our reason for that's going to be the definition of congruent polygons or congruent triangles. Definition, congruent triangles. So now you can try, oh, and don't forget your little Helmos, sorry. Now you can try this proof on your own, and once you have completed this proof, you will have completed your notes for today, and I will see you in class, and thank you for watching.